Hi and good day to everyone. Today I will be presenting our study on population growth, which is one of the most important issue in this modern world. In this project, we focus on Bangladesh, a country known for being one of the most densely populated in the world. The main purpose of this study is to apply the MAT097 model, which is a first-order differential equation represented by the equation dP over dt equal to Kp. And finally, we aim to determine how accurate this mathematical model is when compared to the real population data. Thank you. So next, I will explain about the calculation process. So first, we will begin with the equation dP over dt equal to Kp, where P represents the population, K is the growth constant. This equation shows that the rate of change is proportional to the current population. So first, we separate the variable, which is P terms on the left hand side and T term on the right hand side. After that, we integrate both sides and we will get ln P equal to Kt plus C. After that, we apply the exponential function to both sides and we will get P equal to e to the power of Kt plus C. Using the law of indices, we separate the exponent and we will get P equal to e to the power of Kt times e to the power of C. Since e to the power of C is a constant, we let it to A. So the equation becomes P equal to A e to the power of Kt. After that, we use the initial condition from the data, which is T equal to 0, refer to the year of 2005. The population is 144,750,786. And we substitute this data into the equation and we get A, which is 144,715,786. And we substitute A into the equation and we get the general equation. After that, we determine the value of K, which is the growth rate. We use another data, which is T equal to 1, refer to the year of 2006, where the population is 146,405,973. We will substitute this data into the general equation and we will get K, which is 0.0116. After that, we substitute back this K value into the general equation and we will get the particular solution.
So in this part, we are trying to use MAT097 model to calculate the past and also future value. So the past value here refers to estimate the population before the starting data year. So in this case, we are trying to predict the population in the year of 2000. So from what you can see in the final answer, there is only a slightly small difference between the predicted value and also the actual recorded population, and that indicates that the model is still reliable in predicting the past value. On the other hand, the future value is we are trying to predicting the population beyond the available data. So by using particular solution, we are trying to estimate the future population in the year of 2026. So from what you can see, the model predicts that population will increase and will grow exponentially. However, it may not be fully accurate as the model neglect the real world factors that may slow down or overestimate the population. So moving on to the next part, we have a graph here that shows two sets of data. The green one represents the actual population in Bangladesh from 2005 until 2025, while the red one is the value that we obtained by applying the MAT097 model. So the x-axis represents the year while the y-axis represents the population, and from what we can see, both curves shows increasing trends, indicating both of it growth exponentially. And from the predicted value, which is the red one, we can observe, we can see that model closely follows the actual value, although the slight difference can be observed.
To begin our analysis, we compare the result of our particular solution against the actual recorded population data. For the year 2000, our model calculated an estimated population of 133,561,043. The actual value for the year was 134,544,304. When we place these figures side by side, the difference is very small. This alignment proves that our exponential model is consistent with reality, providing us with a highly accurate approximation of how the population was actually trending during that time. To quantify the precision of our work, we perform a percentage error calculation. We took the absolute difference between our estimated value and the actual value, divided it by the actual total and multiplied it by 100. The result was a percentage error of only 0.73%. In scientific modeling, staying well under the 1% threshold is a strong indicator of success. It demonstrates the formula we have derived is not just a close guess but a mathematically sound representation of the dataset. While the error is minimal, it is important to understand why our calculated value isn't a 100% match. There are two primary reasons for this slight variance. First, the assumption of constant growth. Our model operates on the assumption that growth is perfectly steady and continuous. In the real world, population data is far more complex. It is influenced by short-term changes in birth rates, mortality, and migration that a smooth exponential curve cannot fully capture. Second, rounding during calculation. Throughout the various stages of our mathematical process, minor rounding of decimals inevitably leads to slight differences when we arrive at the final 9-digit population total.
Next, we jump to the number 4. The first factor that influence the population growth in Bangladesh. First, the high birth rate due to the cultural needs and also the limited family planning. Secondly, the urbanization. People move to the cities for the better results and also jobs. Third, the refugees and migration from the neighboring country like Myanmar and also India. These factors are that drove to the fast growth. Next, we go to the future factor that influence the population growth in Bangladesh. First, the urbanization still the same. Second, the economic development that reduce family size. Third, the climate change may displace the million people, and also the decreasing fertility rate.
In conclusion, this project successfully applied the multi-shade model to analyze population growth in Bangladesh. The results show that the model provides a good approximation of actual data. However, due to their assumption of constant growth, the model has limitations when applied to real-world situations. This study highlights that the importance of using mathematical model while also understanding their limitations. Overall, this project improves our understanding of how the first order differentiation equation can be used in real-life application.